Hello everyone, today we're going to be talking about another method of factoring, and that's going to be factoring sum and difference of cubes. So notice that we have both the sum and difference, so this is different than squares, in which squares we can only have a squared minus b squared. That's the only way that will work. But for both of these we can have the sum or difference. Now, we're going to go through kind of the process and how we get some of these things, and then I will show you the overall big picture. So you may not need to copy all of this down. So we're going to start off over here where we have either our sum of two cubes or our difference of two cubes. And so then we're going to show how we get all of this as we progress through. So the first term that you're going to find, you're going to take the cube root of the original first term, and that will give you your first term. That works in both the sum and or the difference. And then the second piece you're going to find is going to be the cube root of the second term. And you're not going to take into consideration the sign. We will discuss signs in just a minute. So even though this is a minus and this is a plus, we are only just looking at the b to the third and b to the third. Once you have these two, or these two, again we're going to deal with signs in a minute, is you want to say square. So this is what this s up here means. We're going to square the first term. So we get a squared, meaning we're going to square this piece. And then we're going to multiply the two. So a times b is ab, a times b is ab. And then we're going to square the second piece. So we're going to square b squared. And so we end up with SMS, or square multiply square. And that's how we're going to develop our terms, and we're going to do our terms first. After we have our terms, we need to find our signs in between each one. So we have our terms all in here already. And so when we have a when we have addition, or the sum, then we're going to end up with the first sign the same. So we're going to have the same sign as plus. Down here, same thing. We both have minus. Then between these two, you're going to have the opposite sign. So if we had plus here, we're going to have minus here. If we had minus here, we're going to end up with plus here. And then the last one is always going to be positive no matter what. And then that is our pattern. So you do need to copy down this pattern. So this is both patterns completely filled out. If you notice, the only thing different are your signs. And we discussed how we find that with same, opposite, positive. So you'll have to fill in your terms, and then you'll have to continue to find your signs. Some other things that you should know are some common perfect cubes, because we are dealing with cubes now and not squares. So 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, and so on. You can see those. And then on the right side, you can see here that we have variables cubed. So x to the first cubed is x to cubed, obviously. X squared raised to the third is going to be x to the 6th. X cubed is going to be to the 9th. And then here you're going to see that all of these are exponents that are multiples of 3. So any exponent that has a multiple of 3, that variable is a perfect cube, and you can reduce it down from there. So if we see something where we are factoring these, we want to factor completely. And so we have the sum of two cubes. So we have x to the third plus 8. So x cubed is a cube, perfect cube, and 8 is a perfect cube. So we're going to get our terms first. So we're going to have this parenthesis, and then this longer parenthesis. And then we're going to end up with the cube root of x cubed is just x. The cube root of 8, if you remember on the last slide, is 2. And then we're going to square the first one. So we're going to square x squared. We're going to multiply the two together, and we normally say x times 2, but we like to have our coefficients in front, so we're going to say 2x. And then we're going to square the last term. Okay, so this is our square, multiply, square. For our signs, we're going to say the same sign. So this sign is going to be the same as this sign, so we have plus. The next sign we're going to have is the opposite sign. So we're going to have minus. And then our last one is always positive. And so just so that you don't think I'm making it up, we can multiply this back out and see, because we can always check for factoring. So if we distribute this, we're going to get x times x squared is x to the third. X times negative 2x is negative 2x squared. And then we'll have x times 4 is 4x. and then we'll have 2 times x squared is 2x squared. 2 times negative 2x is negative 4x. 2 times 4 is going to be positive 8. When we combine like terms, you're going to be able to find that this 2x squared cancels with this 2x squared, this 4x cancels with this negative 4x, and we'll be left with x to the third plus 8. Secondly, we can look to see factoring completely. So if we look back and see that we have this trinomial right here, we would say what two numbers multiply to 4 and add to negative 2? Well, our only factors of 4, if we wanted to break this up, we would say x and x. Our only factors of 4 are 2 and 4. So if we put a 2 here and a 2 here, and since this is C is positive and B is negative, we'd have to have both negative, which that doesn't work because that adds to negative 4. If we were to try both positives, that wouldn't work because that would give us positive 4. So then we can try 4 and 1. Sorry, negative 4 and negative 1. And again, that's not going to work because those add to negative 5. If we were to change that, it would be positive 5. So we're going to find that every single sum or difference of cubes, this last trinomial will not factor. And you'll find out what that results in at a later time, but you will never be able to factor that any further. Looking at another one, we have x to the third minus 27. So again, we have x to the third, which is a perfect cube, and 27 is a perfect cube. We have subtraction, but we're not going to worry about that just yet. We're going to look at x to the third. The cube root of that is x. Cube root of 27 is going to be 3. That's 3 times 3 times 3. And then we're going to say that we're going to square the first term, multiply the 2 together. So we're multiplying these two in the first parentheses right here. And then we're going to square the last term. Same sign, opposite sign, always positive. I'm not going to check for sake of time in the video, but you can multiply this back out to check. And then again, we can't factor x squared plus 3x plus 9 because nothing multiplies to 9 and also adds to 3. So we know that this is our final answer. Making them a little bit more difficult is we're going to have 8x cubed minus 125. So 8x cubed minus 125. 8x cubed is a perfect cube, just includes a coefficient, and 125 is a perfect cube. We don't have any GCS between the two, and so we're going to go ahead and start factoring. So the cube root of 8x to the third is going to be 2x, and the cube root of 125 is 5. We're going to square the first term, and this is where something you have to pay close attention to. We're going to square the first term, meaning 2x squared, like so. We're going to multiply the 2 together. We're going to clean that up in a second, but we're going to multiply the 2 together, and we can do 2x times 5 pretty easily to be 10x. And then 5 squared is 25. And then we're going to put our signs in just for now. So we're going to say same sign, opposite sign, always positive. But we do need to clean up this number right here. And so we're going to say just carry this down. And then 2x squared, when the 2 is in parentheses, then we're going to say that that's 4x squared plus 10x plus 25. And we're going to find that we cannot factor that any further. And that will be our final answer. Lastly, we don't have a sum and difference of perfect cubes, but we have 4 terms, so we're just practicing some other factoring. And so we're going to practice by factoring by grouping since we have 4 terms. In our first group, we can take out an x to the third. It's going to be left with x minus 1. In our second group, we don't have any common factors other than 1, but we do need to take that out. And then we're going to be left with x minus 1. Again, in order to factor by grouping, we must have the same parentheses. So we're going to take that out, and we're going to be left with x to the third plus 1. Now, normally we would say we're done, but we need to recognize that this is a sum of 2 perfect cubes because x plus 1 is a perfect cube. So we're going to carry this x minus 1 down. I'll use a different color to distinguish. So we're going to carry this x minus 1 down. That's going to stay in the problem. And then the cube root of x to the third is x. Cube root of 1 is 1. We're going to square the first term. We're going to multiply the two together just to make x, and we're going to square the last one to be 1. We have same sign, opposite sign, always positive. And remember that we're never going to be able to factor that last trinomial. And so we get our final answer here. So always be checking for sum and difference of cubes now whenever you are finished factoring any other method. I hope this helps.